Okay, so I told you to basically, whenever you're rotating something, to create like a little line. If you want to use your pencil and put it on the graph right in the center and rotate it the amount of times that you're supposed to, then do it that way. Imagine that this is my pencil, and if I'm rotating 180 degrees, it doesn't matter which direction I go because I'm going to land at the same place. So that's the one time when they won't tell you to go clockwise or counterclockwise. So if I'm going to go 90 is this way, 180 is that way. It's almost like a reflection when you rotate 180 degrees. But the only difference is that the points don't end up in the reflection position. So I'm literally grabbing this thing. A is going to be land over here. It's going to land right here, this A prime. B is one away from, actually, this is what I was trying to emphasize. Over here, when you're at this position, I want you to notice what points are on the line, what points are in front of the line, and which points are behind the line. So point D is in front of the line by 1 unit, right? Yes. It should be on top of the line at all times. So you notice that D is actually, if you go in this direction, if you're going this direction, then D is considered to be on top because you're going counterclockwise. So when you land on this side, then D must be on top of it. 1 unit away, right? On the 2. So you're still rotating on the 2. This is 2. That's negative 2. This is negative 2. This is 2. And this is 2. It's still going to be on the 2 line, but on top. So right here, this is D prime. Yes. Oh, yeah, sorry. Thank you for correcting that one. Okay. And then the B, you notice that it was 1 behind, right? 1 unit behind of the line. That means when you rotate in the same position, it should land right here. It's 1 unit behind the line on the 2. And that's B prime. The what? No, D prime is the top. Because if you notice, hang on. If I rotate 90, look, D is right in front of it, right? Right? So when I rotate, I'm grabbing the D and it still stays in front of it and B stays behind it. So D is right here at this point, and then B is right there, right? If I rotate one more time, D stays in the same position, which is on top, and B stays behind. Yes. This is the visual. I do this so you can understand the rotation. Well, because if I just tell you points and I tell you images, you won't know what to do. You have to understand that you're rotating, you're going around it, and I have to visually show you that the picture is literally going around it. So just, I mean, if you don't get it, rely on the other stuff. Ignore this part. But I cannot take that away from the rest of the kids because you don't like it. I'm what? Okay. Hang on. Maybe this will help you. Not that. What am I doing? And I'm gonna color that one that a little lighter color, and then this one a lighter color. I want you to focus on the point, and I want you not to lose me. This image right here is literally rotating around there. So point B and point D never leave that circle. That's the reason why I'm using this right here, because if I was able to grab the image and stick it to this little line, it will go in the same position. It'll be right there right now. It'll be right here right now. That's what I use it for. Do you see that? That's the rotation. Every point when you rotate needs to stay within that same circle, on the same spot of the circle. So if you rotated D, then it should be right here, and B will be behind it, which is right there. When you rotate it 180, then D is right here, right? And then B stays behind it. If you rotate it at 270, then D will be right here, and D will be behind it. But they never leave the circles. Exactly. The 8 points all stay connected. They're all in the same circle. And you rotate them that way. And then the C stays in the middle. It doesn't go anywhere because it's the rotation point. Yes. I think it's going to help you because it will keep you from staying outside the circles. But the problem is that you do not have a compass. So you say it? Yeah, you don't have one of those. So it'll be difficult for you to create those perfect circles. Yes. I'm sorry? It's still C prime because even though it's in the same spot, it's a new position for the for the image. So again, if we're rotating, let me erase all this mess. If we're rotating this image 90 degrees, where would it land? At the bottom, right? On red and blue. I can easily connect the dots because the lines do not let me get out of them. The circles, they do not let me get out of them. I know I have to land on the circles. And if I wanted to go 180, then I know I have to land on this circle right here and on this point, and then I can just connect them. So this will be, well, because the blue one we ignore. D stays right here. B stays right here. Are you okay? Yeah? And then A's right here. Are we all following? Good. Well, I was before I had to say what I had to say. So for the next one, I'll start with the circles, and then we'll see how the positions change, just so that you can see what happens. Actually, those are in the same circle, and then those are in the same circles. The what? Go ahead. Yeah, go ahead. The what? I'm sorry? Well, you tell me. When you rotate 90 degrees, how how many turns do you take? A quarter, right? You go a quarter of the circle. So from the red to the blue, how many degrees is that? There you go. Exactly. And if you went from the red to the one that I didn't draw, it'll be 270. Yes. So let's try the other one without, now that I drew the actual circles around them. I'm going counterclockwise, right? Hi. You can sit. I don't need that. Oh. All right. So which direction am I going if I'm going counterclockwise? This way, right? I'm going this way. And 270. So if I go, you won't. I'm just using this so that you can see that I'm staying within the lines. So I'm gonna use again the line that some people hate, but that's fine. And I want you to look at the points that are in front and behind this line. Which points are behind it? Behind it. B, this is behind, this is in front, because we're rotating to the left. So B, right? How many units from the line? 1. On which number? On 2, right? So if I'm rotating this guy, not 90, not 180, but 270, where should B be? Behind on where? How many units? 2? 1. Sorry. Okay, so I go to 2, and then it has to be 1. And notice that it lands on the dot, on the line 2. Now, C and A were in front of it. How many units in front of it? There were 2. On which numbers? 4 and 1, right? So 1 should be right here, and 4 should be right there, and then 1 should be right there. That was wrong. It doesn't stay. It rotates. So now who's in front of where B is now? A, right? Because A basically went around over here, and now A is right here, and B is right here, right? That's why I told you to be careful which one's behind and which one's in front. Because B is behind the line, and A is still in front of the line, and then C is right here, right? And now you can draw the next one. Now look at it. Is A and C still in front of the line? Yes. Is B still behind the line? That's all you need to do. The what? The circles. Notice that the points do not get out of the circles because you're rotating like the earth, like the moon rotates around the earth. Yeah. It doesn't get out of the orbit. It's the same way. Those points do not get out of the orbit. And neither are the ones outside. So usually, depending on how many points you have, that's how many circles you're going to have. But sometimes those points end up on the same orbit, like point A and B are on the same orbit. They'll rotate in the same area. And C is the only one outside. And probably, yes. If 2 of them rotated in the same orbit. That what? I can only show you by this. Because if I'm sticking the image to this line, then when I go here, it'll be 90, right? Which is what? Which is 270. We only doing 90, 180, 270, and 360. But 360 is kind of dumb. Why? Same spot. Same spot. That should be what's all the way. Yeah. I wish I could move that, and I can't.
The shape?
Yeah, I wish I could rotate it. The what?
Make the shape and then trace it around.
No, because I have to set the point of rotation in the middle, and I don't have that. So when I rotate an image, it rotates within itself. So let me show you. So when I create this image and I rotate it, look, it rotates within itself. It doesn't rotate around anything. I have to grab it around. I have to grab it and do this. And that doesn't work. No. These images are rotating around the 0 point. They're not rotating within themselves. What do you mean? This in the middle right here? What about them? We're in touch with what? No. Well, the image and the pre-image, you mean?
Yeah.
Or yeah, they would, because they have to go around the same circle. I'm saying this one right here, I don't want to rotate. Where's the point of rotation here? The center of the image, right? The point of rotation here is not the center of the image. Where is it? the origin, right? It makes a huge difference. You should have learned this in science. Point of rotation is a scientific thing. Yes. Okay, hang on. Where? Let me show it to you visually. Point A is the tip. Point B is the back, right? Look what happens when I rotate. Where is B? Yes. The letters move with the shape in the same direction. And B will always stay behind. Do what? Yeah, just like this one. Imagine that I am limited to where I can go. I can't get out of the circle. So C will always stay in front of it and B behind it. You see it? The whole thing transfers at the same time. I want you to think about it that way. That's why I say use the pencil, because the pencil helps you see that. All right. I wanted to take a little more time on this one because I know some kids didn't quite get it. Hopefully, these visuals help. For some people, the visuals don't help. Sorry. I maybe this part, which is the algebraic part, you'll get it. Yes. What do you mean not to connect? They don't necessarily connect. Uh, this one doesn't connect, except for the middle point. But if it was farther out, they wouldn't connect. Well, hang on, they don't have to. Because if I asked you for a 180-degree rotation, it would end up at a different position. So A would be, well, B is behind, right here. And then A is 2 in front. Is it? On, it's 2 actually from here. I don't know why it's not on that one the same way. Oh, it's right here. And then B is behind, and then C should be in the same, right there. I don't know why it's not exactly on there, but it will land around here. So you notice that the points don't touch. They just stay in the same orbit. Oh, yeah. But what if they were skinny like this? Like the first one. They don't touch, only the center. What I'm trying to emphasize is they don't always touch. This is just a particular example. But most of the time they won't touch. I don't want you to think that you have to touch connect the images. So from here to here is 90. From here to here is 180. And then from here to here is 270. That's where we were. It's not about the y or the x. It's just the positioning of where it is as far as the rotation line. In your book, for the next part, we already learned this, 251, but 351. I'm sorry, but on this one they're teaching you the rules. The rules are basically what I told you on transformations, on translations. If you're going 3 units up, what do you do to the values of the coordinates? You add 3 to which one? To the y, right? Because it goes up or down. If you're going 3 to the left, what do? You subtract from the x, right? Well, that's all that it means right here. You don't need it. I mean, you can, but you don't have to. You know that if it says go up, you add to the y. If it says go down, you subtract from the y. If it's saying go right, you add to the x. If it's saying go left, you subtract from the x. That's all it means. So you have your original vertices, the rule, which is whatever you're doing to them, or the command, what I call, and then the final ones, which is the prime ones, right? We already did this, but I think it's easier when we do it. Well, if I can find it. Come back. Here. When we do it this way, right here, where you get the original, then the additional subtraction of the x and y, and then the new one. I think it's easier doing it that way than having to put it on a table. Or like these right here. When I just give you the original, the command, and then the green one, which is the new one. So whichever one you prefer, it doesn't matter. I just think this is a lot easier because you're actually adding and subtracting right on the spot. So let's go back to this. That's just for transformations. We're not going to do that. Yeah, for translation, which is part of the transformations. For reflections, I told you to do two things. If you're reflecting across the x-axis, what do you do to the coordinates? If I have these coordinates, whatever they are, and this is my x and y, if I'm reflecting across the y-axis, what do I do? I told you to do something with the coordinates. I'm sorry? I'm reflecting. You really need to watch those videos. I told you that this in class, and my other kids got it, and I don't understand why you don't. Which ones? Which ones? Tell me, because I told you that yesterday. If I'm reflecting across the y-axis, what do I do? I save the y and I change the x, right? That means I cannot touch the y and the x stays the same. What if I'm reflecting across the x-axis? So I save the x and I change the y. This sounds simple, right? This thing tells you basically the same thing, but it tells you to multiply by a negative number, by -1. So it says, do not touch the y, but multiply x by -1, which in effect changes the sign. So instead of you thinking, I have to multiply by -1, just know that you have to change the sign. It's the same thing, but you probably will see this on the test. That is the rule. That's what they call it. So if I want to take that one with you, well, actually it's in the video, you don't need it. Do we have any questions on this? Reflection should be pretty easy. The next one is going to be rotation. And rotation has 3 of them that you might have to kind of memorize. So you might want to take that one out after the class. Here's the thing. If you're rotating clockwise, meaning going the way that the clock goes, then you multiply by -1 the x-axis and then swap the values. It sounds crazy, but it makes sense once you read them. So for example, and then if you're going counterclockwise, you multiply the y by -1 and then swap the values for the new coordinates. If you're going all the way to 360, pick up. Then you multiply both of them by -1. Is it the visual part or the numerical part? If you want, you can buy a little compass. They cost like $1. And then just draw the circles around each point. So from the middle, drag it to a point. You can't use them. That's just for you to learn it. So yeah, you really can't. Because yeah, it's not part of the things that you can use. So for example, this one right here, I think it went all the way up. Yeah, and it's big. Yeah. This is also what it's called. Oh, it's so big though. I don't know how to make it smaller. That changes it. So basically, you position this thing in the middle, right there, and then you grab this guy, and you do that. But you have to position the pencil. Ugh. It's stupid. I can't use it on this one. But you have to position the pencil right on the dot. You won't use it. I'm just showing you that so you can understand and get used to it. But you cannot use it on the star. You won't. I mean, it's not such a big deal, that's why. No. Other than multiplying it, yeah. Okay, so for this one, pay close attention. We are rotating 90 degrees clockwise. And this guy right here says that if I'm rotating 90 degrees clockwise, I have to multiply the x by a negative number. In other words, the x value switches signs. And in the second part, you have to flip them. So the x becomes the y and the y becomes the x. It can get a little confusing, but just watch and do not lose me here. Here is our current value, right? X is negative 4, y is 2. It says that I have to turn the x, multiply it by negative 1. What is negative 1 times negative 4? Positive 4, right? So I should get positive 4. They should have put that over here. Negative 4. Yeah, positive 4, right? So when you multiply negative 1 times negative 4, I get positive 4. The 2 we don't touch. And then the second part says, then switch the x and the y coordinates. So the 2 is now the x, and the positive 4 is now the y. So there's two different things going on. So let's do one more. I don't know why they did it this way. It's so stupid. And then, so again, you multiply the x by negative 1. So negative 1 times negative 3, what does it give me? Positive 3, right? So, and then you flip the sign, the numbers. So positive 3 now becomes the y, and 4 becomes the x. Same for the next one. And then 3. We don't touch the y, but we multiply the x by negative 1. So we get negative 1 times 2. What do you get? Negative 2. And then we switch them, so the x becomes the y, and the y becomes the x. Are we understanding that part? Good. Now, you're going to have an opportunity to do that in class by going over here to the following page. Yes. Pay attention to the vertices and do those and create, no, that's yeah, it is rotation. And then create a little table that shows me the rotation. So basically, the original vertices, the multiplication, and then the switch, and then the new one, and that's it. Voice, la voce. All right, so here it is. You can check your answers now. Here are my original vertices. Then the rule says to go counterclockwise, which is that I change the y values, right? Yes. So the y values get multiplied by negative 1. The x does not do anything, right? Actually, I won't do that. I'm going to circle the x, and the y will change, right? Yes. So the x's stay the same, and the y's get multiplied by negative 1. So negative 1 times negative 4 gives me 4. Negative 1 times 5 gives me negative 5. Negative 1 times 2 gives me negative 2. And then he says that you have to flip them, right? So the x becomes y, and the y becomes x. So the 4 now becomes the x, and the 2 now becomes the y, the negative 2. And the same thing happens for all of them. Like I said, a good way of doing this without having to think about multiplying is that whatever you underline, just switch the signs. Switch the signs. So negative 4 becomes positive 4, positive 5 becomes negative 5, and positive 2 becomes negative 2. It's a very easy way of thinking it that way. Just switch the sign. Like reflection. I'm a little kid. right, so you're gonna have plenty of time to work on these. So go to the ones that I asked you to circle. Oh, I didn't? JK. So go to page 352 and circle number 1 when it says your turn. Your turn, your turn. On page, your turn on page 352 and 353. 352 and 353. And then the page 355, the whole front page is going to be your homework. Es que no pone atención. Yes, the whole front page, not the back.